In this podcast, we will talk about how ionic bonds form in more detail, and I will show you how to calculate the amount of energy change. Our goals for this podcast will be that when you are done, you can calculate the energy of ionic bond formation given the necessary ionization energy, electron affinity, and the attraction of plus minus ions. You will be able to determine if forming an ionic bond is exothermic or endothermic, and therefore whether it is energetically favorable or not. I need to give you a very brief introduction to energy first. All chemical processes either consume or release energy. The two words that we use to denote this exchange is endothermic and exothermic respectively. So endothermic if it's taking in energy, exothermic if it's releasing energy. In 1B, you'll do a lot with exchanging of energy. Here we're just going to talk about it with respect to the area of ionic bond formation. To calculate the energy, we are going to break the process of forming the ionic bond into 3 parts. We will use the example sodium chloride. The 3 parts include, first, ionizing sodium into sodium plus, then giving an electron to the Cl to form Cl minus, and then seeing how much energy comes from the plus and the minus attracting each other. So on this slide, we're starting with the ionization energy. In order to form an ionic bond, sodium must become a +1 charge. As we learned about in last chapter, there is an energy associated with that. And this is called the ionization energy. For sodium, that's 494 kilojoules per mole. For the next part of this process, chlorine must gain an electron to become Cl minus. As you remember from chapter 1, this is called the electron affinity. For chlorine, we can look that up and see that it is negative 349 kilojoules per mole. And then for the final step, the positive and negative ion are going to attract each other. This also changes the energy, and in this case, it changes it by negative 787 kilojoules per mole. You don't have to worry about exactly how to find each of these energies. They would be given to you, so just have the process down. Now that we figured out the energy of each of the 3 parts, we can add them together and get the total energy change. If the total energy change is negative, this means the total process was exothermic. Negative energy equals an exothermic circumstance. It releases energy into the environment. Let's think about what must be true in order for this to be negative. Since we need the exothermic value, this positive value ionization energy value right here must be low enough that it does not counteract the negative values for the electron affinity and the plus-minus attraction. So I'm going to say that one more time. This positive value right here must not be so large as to counteract these negative values here, since we want this overall value to be negative, otherwise known as exothermic. So in summary, now, given that I give you the 3 values for ionization energy, electron affinity, and the attraction of ions, you should be able to calculate the ionic bond formation energy. You should then be able to look at that and decide, well, is this a negative? And if it is, that means it's exothermic, which means that it's energetically favorable. So these are the sorts of questions that you will be asked in class and on exams.